Hello everyone, today I will be showing you integration by parts. We will be using the DI method, which is actually the same as the DU/DV method, but it's the same thing, but it's just more arranged. There are three main parts. There are main three sections to integration by parts, and that is the first stop, the second stop, and the third stop. Let's start. So integration by parts, it's very simple. Just integrate it by parts, simply. So let's look at the first example. Let me check if you can see it. Oh, that's a bit too high. Okay, fine. Give me a moment. Okay, so there you go. The integral of x sine x and then dx. So how do we integrate this? By parts. First of all, when we do the DI method, we want to draw a D and an I. D stands for differentiate and I stands for integrate. And also we have to do plus and minus and so on. It goes on forever actually, but it depends on how many times you differentiate and then you write more as you continue on. You can only write 2 for the starting, or you can write more if you want. So we have to pick which one to integrate, which one to differentiate. Usually I recommend you pick the one you differentiate first. There is something called the Liate like the Liate method. Not method, but like it's like the order of differentiation, Liate, but it doesn't always work because sometimes there are two of the same type of functions in the same whole integral, which is a little confusing. So you just have to look at it. It's not that hard though. So let's pick x to differentiate. The best one to differentiate is the one that goes to 0 the more you differentiate it. So you'll see. Let's draw another one. We will be integrating the sine of x. Differentiating x, we get 1. Integrating sine x, we actually get cosine x, minus cosine x. Differentiating 1, we get to 0. This is what I mean. You want to pick the one that you can differentiate to 0. And then integrating minus cosine x, we get minus sine x. Let's see if you can see it. Okay, you can. And then what you have to do now is multiply your answers diagonally, like this. And if you multiply it diagonally, you get the answer. If you multiply it flat down, like this, then you get an integral, which for now you don't have to worry about it, but on the second and third stop you will have to worry about it. So we multiply it sideways, what do we get? We get x times minus cosine x, have minus x cosine x, and then minus 1 times minus sine x, we get plus sine x. And there you go, plus c. There you go, integration by parts. Done. That's the first stop. When you reach 0 in the differentiation part, you stop and then you write the answers. This one is quite simple. But the next one's a little bit trickier. Not that bad though. Okay. Second one, let's write it down. Integral of x and then natural log of x and then dx. Okay, you can see it. Again, this one you can differentiate, this one you can integrate, but think about it. It's not always that you should pick the one that differentiates to 0, because if you differentiate x, you go to 0, right? But what if you integrate natural log of x? That would be very hard. So I say we differentiate natural log of x instead. So write the di and then the plus minus. D, we will differentiate natural log of x, and then I, we will integrate x. Differentiating natural log of x, we get 1 over x, and then integrating x, we get x squared over 2, and this is where we stop. Why do we stop? The second stop is You stop if you can integrate a row. So we multiply this diagonally. Remember, if we multiply diagonally, we get the answer already. If we multiply it flat like this, it's an integral. So what I mean is, multiply diagonally, we write, this is the answer now, right? Natural log of x times x squared, and then over 2, and then minus this times this, but as an integral because it's flat. We didn't multiply diagonally here. So we have to minus and then an integral of these two multiply to each other, and the minus is here. So this times that is x squared over x over 2x, or x2, same thing. But here's what I mean. We can integrate the whole row easily now because x and x squared cancels off to x over 2. And that is actually equal to x squared over 4. So now we get the full answer, which is x squared. Let's just write it like this: 2x squared natural log of x, and then minus x squared, and then whole thing over 4. You can factor the x squared out if you want, factor 4 out if you want. Depends on you. But yeah, plus c, and this is the second stop. All right, time for the third stop. Okay. The third stop is here, this function. So let's write it down. Integral of sine x cosine x dx. Again, let's write the d and then the I and then the plus minus. Which one would we differentiate? Well, let's look here. Let's differentiate sine x. Integrate cosine x. What happens when we differentiate sine x? We get cosine x. What happens if we integrate cosine x? Well, go back to sine x. And now we have to stop. Why? Because the integral repeats. If the integral repeats, you stop. What I mean is, we multiply this, we get the first part of the answer, and then we multiply this flat, we get an integral, which if you look carefully, cosine x times sine x is the same thing as here, cosine x times sine x. The integral repeats, and I'll show you how we can play with that. First part of the answer, sine x times sine x equals sine x squared, and then the next part is this, as an integral. So minus from here, and then an integral of sine x times cosine x, and then dx. Now, what do we do now? Remember, this is the answer to this, right? So let's write it here. Sine x cosine x dx. This integral equals this minus this integral. So what do? We can move this thing to the other side. And what happens then? Well, this disappears. And guess what? There's a 2 here, because 2 of the integrals equals this. And now what? We can divide by 2. Cancels, cancels. And then boom, done. Plus c. Let's rewrite it again. Sine x squared over 2 plus c. Done. That is the third stop. The third stop is when the integral repeats. When the whole row becomes the integral itself, then you stop. So I'll write the summary down. And that is it for integration by parts. So first stop, D column reaches 0. Second stop is when you can integrate a whole row. When can integrate row. Okay, and then the third stop is when when a row repeats the integral. There you go, 3 stops. And yes, that is it for integration by parts.